All right, we have a Microsoft branded machine up here on stage finally. It's been, I think, MacBooks all day long, so that means it must be time to talk about .NET. So I'm excited to introduce Shahab, who is a solutions architect. Shahab, take it away.
Hey everybody, my name is Shahab Mohsen, and I'm a senior solutions architect working for Amazon Web Services. My specialization is for Microsoft .NET development. I also have a lot of background development in Java as well and DevOps. So today, if you're wondering why you're here, why do you care about Microsoft Workloads, this is like pretty much startup conference. So I'll tell you why, and we will go over that as well. Also, if you have like .NET framework and you are like interested in legacy Microsoft like .NET applications, I'll talk about that a little bit as well. So what I will cover, I will quickly go over Microsoft Workloads on AWS, talk about .NET development, the tools that we give you to make your lives easier if you are a .NET or .NET Core developer. And I'll talk about containers, serverless, and quickly cover CI/CD. And if time allows, I'm doing like as many demos as I can for you today as well. So just quickly giving you a history that we started like publicly provide like services for Windows instances and Microsoft Workloads in 2008. And since that time, we delivered like many services for compute, for databases, for .NET, and for like application modernization and serverless. So we have more than 10 years of experience of running Microsoft workloads on the cloud, and that's even longer than many of other providers they even like existed. Also, another thing, as a startup, you might think that why Microsoft? Why is this guy talking about like .NET? 70% of the enterprise workloads, they run on Windows. You can think that how many developers, how many .NET developers are there in the market. And there is .NET Core, which is open source. And if you choose your next like language for your startup as .NET Core, it opens a door to the pool of software developers for you that they are there in the market, they are experienced, and they know what they are doing. Also, that's about like Microsoft Workloads, and now why AWS. It's very like it's interesting to know that like IDC announced that more than like 57% of Windows instances they run on AWS Cloud. So we are almost twice as more we are like running twice as more instances as our like next competitor of Windows instances on AWS Cloud. So we have been doing this for long, and there is actually no comparison algorithm for experience that we have had for it. Before we go to like .NET, I just want to tell you a little bit of, about our infrastructure. And this is very important for you to understand, because when I will talk about like development, there will be minimal knowledge required to know about infrastructure. AWS, it has different regions, and within the regions, it has different availability zones. So we have like more than 20 regions, more than 60 availability zones, and more than 150 points of presence. And these points of presence are like content delivery networks. They are like, we have presence so we can connect to our back end from these points around the world. And then talk about like a region. A region is consisted of different availability zones, and each availability zone is a cluster of data centers. The very important point about these availability zones is that they are close enough to each other that, for example, you can do a synchronous replication between your DBs between two different availability zones. So like probably the latency of the like network is like in terms of like single-digit milliseconds, but they are far from each other, so they are on different disaster planes. They are on different like flood planes or electricity planes. So if a disaster happens in one availability zone, the other one does not get affected. So when we talk about for example, a web application that most of us are like interested in, this is a traditional design you can do on AWS. So you can have multiple, you can take leverage of multiple availability zones. You can have a load balancer in front of your application, and that load balancer, it will divert all the load to different servers running on different availability zones. So in each availability zone, you can have a server, for example, for the web layer or for the application layer up and running. And between your application layers, you can again have internal load balancers as well. So, and at the back end, you can use like RDS databases that's doing a synchronous replication of your data in the backend between your servers. So if one of the instances goes down, you don't have to be worried about losing the data. RDS takes care of that. It will give you the DNS, the DNS it gives you. It actually can direct the load between your master and your primary and secondary nodes. So if the primary goes down, it will direct all the calls to the secondary, and it will bring up a primary node in the backend and bring it up. This is just a quick note about like the infrastructure that in AWS. So now let's talk about .NET development. And if you are a developer, we do, like AWS provides you different tools that you can take advantage of when you are writing your .NET applications. One of them is the AWS SDK for .NET. We'll talk about that a little bit more. Like we have an SDK that you can use AWS services from your .NET code using like those libraries and SDK. We have AWS tools for PowerShell and AWS Toolkit for Visual Studio. From PowerShell, you can actually control your AWS instances. You can make API calls. And from we do have the AWS Toolkit that I'm going to demo you in like a few minutes, that from Visual Studio, you can actually create virtual machines. You can create a database. You can deploy your code to AWS. You can explore your services in AWS. And we also have Visual, like if you already are using Visual Studio Team Services or Team Foundation server, we do provide toolkits that you can actually directly from TFS, you can deploy your code to AWS Cloud. So when it comes to Visual Studio, I'm quickly going to go over this. There is the toolkit for Visual Studio. We do have the NuGet packages that provides you with the SDK for .NET, and we do have tools that you can use in your command line or in your PowerShell to talk to AWS services. And talking about the SDK, you can also you can almost talk about have your .NET code talk to over 100 AWS services from your .NET application. This can be your S3 object repository. This can be deploying a code to production, not production, to your dev environment, or like accessing your DynamoDB, which is NoSQL database. So the toolkit for Visual Studio, it has the following modules. It has the Explorer. You can deploy to Elastic Beanstalk, which I'll cover quickly. You can deploy to Serverless directly from AWS, and you can deploy into containers and containerize your application and deploy to AWS from the Visual Studio Toolkit. So before I go to the demo, I'll tell you about the Elastic Beanstalk. And Elastic Beanstalk is the service that, as a startup, you will be interested in. If you have a piece of code, you only have like 2 developers, and you want your developers just to write the code, and you don't care about like setting up the infrastructure, setting up the servers, setting up like the network and like the like security and anything, you can just write the code and have Elastic Beanstalk deploy that to the cloud. It can deploy, for example, your web application to the cloud, give you an endpoint that you can access your application. So let's go to Visual Studio and take a look at what this toolkit looks like. So I'm running Visual Studio 2019. On the left side here, it's actually, you can see the AWS Explorer. On the Explorer, I can directly access like Amazon S3. I can right click and I can create a bucket here. I can say Shahab's new bucket for collision. It should have a unique name. And under this bucket, I actually can put my objects directly. So for example, if you want to put a picture and test a piece of code that takes that picture and analyzes and sends it to Amazon Recognition, for example, to see what's like, if there is a chair in the picture or if there is like a human being or a cat in the picture, you can directly do it from like AWS Visual Studio Explore, the toolkit. Also, you can create like messaging queues from here. You can create a SQL Server instance from here. So for example, if I go to RDS, I can click on instances, I can right click, and I can say launch an instance, and I can launch a SQL Server instance, right click from Visual Studio. So this is one functionality that comes with this toolkit. Another functionality that comes with the toolkit is, actually my laptop is a little bit slow, so you can choose from the range of databases you want to launch. It has from Postgres, Aura, MySQL, SQL Server. You can actually launch a database instance. So, if you're a developer and you need to test something, you can do it from Visual Studio directly here. So another thing is that you actually, as a developer, another thing you can do is you say that I just want to write my code, and I want Elastic Beanstalk, which is the AWS service, to create the backend network for me and deploy my code to the production. And what Elastic Beanstalk can do, it can actually bring up in 2 different availability zones. It can bring up different servers, so and put a load balancer in front of that and set up all the network securely. So if one of the servers it goes down, the load balancer can redirect, can send the network traffic to the one that's working and bring up another instance instead of the one that failed. So here what I did, I actually didn't do any kind of magic. I just went and created a new, from template, a new MVC ASP.NET Core application here. And I go to File, New, Project, and I just created a ASP.NET Core web application. That's all I did. And after I created that one, here you can see it's Docker because I right-clicked on the project and added Docker support. But when you run the code, it actually looks like something like this. You can run it under IIS, you can run it under Docker. There are different ways to run it. And I'm just, this project that I'm running, this application is actually containerized. And I'm going to show you how it looks like when it runs on the container. So let's give it a second. My laptop is a little bit slow. It's bringing up like the application locally. Probably, if you are a developer, you have seen this page hundreds of times like, if not thousands of times in your life. So this is what happens when I run this code locally. So now let's say that I have done the development, the code is there, I want to push it to the cloud. I want AWS to actually deploy it to virtual machines for me. So I right-click on my project, and it will give me the option to publish to AWS Elastic Beanstalk. I can say, hey, please publish that to Elastic Beanstalk for me. I can say that create a new application environment for me, or choose from the existing one, and say, hey, this is going to be like a test environment. This is my URL. Let's check it is available. I go next. I can do a single instance deployment or a multi-instance deployment. If I uncheck this one, what it happens, it will create in 2 different availability zones inside your network, inside your VPC. It will bring up a server in each availability zone, and it will like go with an active solution. Right now, for the purpose of demo, I'm not touching this. You go next. You set up the roles and the permissions, and it actually pops up everything for you. You don't have to change anything. If you know what you are doing, you can set up like the permissions yourself. And you can just deploy your application and choose like the framework that you are working with. And right now I'm using .NET 2.1. We do support later versions of .NET as well. And after I click on publish, I click on deploy for like, I prefer the demo because the network here is like pretty like not very stable. So when I go to Elastic Beanstalk, I've created like this collision demo prepared, and it will give you a URL like this. I click on the URL, and actually it took my code, it deployed it to the production, not to production, it deployed it to the cloud for me, and created like a URL and gave me the URL. So I just wrote the code. All the backend is created by AWS for this purpose. So let's go back to the slides, and I want to tell you more about like containers. Just 1 second. So if you are a .NET Core developer, in the modern world of development, you will be hearing a lot about containers, Kubernetes, and different options that you want to containerize your applications and deploy it to the cloud, or to even to your on-premises. Why are people interested in containers? There are many different reasons, but mostly I would say that it makes the DevOps process really easier. And also, when you deal with the containers, you never face one of those situations that the developer says, hey, my code was working on my laptop, now I deploy it to production, it's not working. This is not going to happen. The same container that you are going to run it in your laptop, you're going to run it in your development, test, pre-prod, prod, in different environments. So for the purpose of the containers, AWS provides you different solutions. And one of the solutions is Amazon ECS, or Elastic Container Service. And Amazon Elastic Container Service is a service that enables you to create a cluster of machines. And these virtual machines, they are going to host your Docker containers, your containers. And you can run these containers on Amazon ECS. Amazon ECS will create these containers for you. The only thing you need to do, you need to set up like tasks and services. And these tasks and services are the definition of what's, like for example, how much memory does a container need? How much CPU power does a container need? Or when you actually create a service, you can say that how many containers do I want when I'm auto-scaling, when I horizontally scaling, how many more containers I want to have? Or when I'm scaling down, what's the minimum number of containers that I'm going to create? There is some manual work when it comes to Amazon ECS. The good thing about Amazon ECS is that it does handle .NET Core, and it does handle Windows containers as well. So if you're dealing with legacy or .NET Framework applications, let's say that .NET Framework 3.5 even, Amazon ECS does handle that, and you can deploy your application to Amazon ECS. So just giving you like a quick overview of what's the difference between .NET and .NET Core is .NET was released like in 2002 and it's actually only runs on Windows. So when you have a .NET application, you actually have to pay for the Windows licenses. When we are talking about .NET Core, you can run them not only on Windows instances, you can run them on Linux instances as well. So we are getting rid of the licensing cost. And that's why .NET Core is one of the choices for startups to develop their applications, because you want something open source. And you want something which is, there is a like big company behind it which is supporting that. And Amazon actually, the SDK, Serverless, Elastic Beanstalk, it supports like .NET, different versions of .NET, even the latest releases, which is like 2.2 .NET Core and like .NET Core 3.0 preview, it's supported by Amazon services as well. So I don't want to I don't want to focus a lot on differences between .NET and .NET Core. Just keep it in mind that .NET Core, it's open source and you can run it on Linux instances as well. And another thing I should mention here is that the Docker image for .NET Core, they are pretty small. They are like 100 meg or even less. So when you actually launch an instance, it is just like any other Linux instance. It's a matter of like second to bring up like another container and have your application up and running. However, when you're talking about like Windows containers, it's not as bad as like launching up a VM, but it still like can be like about a minute of time to bring up the Windows container, start up IIS, and bring up your application. So when we talk about containers for .NET applications, why are they good? They are good because you can utilize your operating system more. You can utilize your operating system better. It gives you like deployment consistency. As I said, the developer says the same container that runs on your computer, it will run in different environments as well. And it's very fast and easy to scale as well. Another thing, if you are .NET shop or legacy .NET shop, a very good thing is that with these containers, you can save a lot on licensing because you can run multiple instances, multiple containers on the same Windows server. And what happens is that if, for example, you are 4 containers running on the same Windows servers, these containers, they have all of their processes isolated, so they are qualified for a lot of compliances, and you are paying for 1 license versus 4 licenses. So this is like more about like Windows Server and ECS. I just want to quickly touch base that it's a Windows Server. There is Docker for Windows that we do support that, and Amazon ECS, Amazon Elastic Container Services. You can, even if you are dealing with legacy .NET applications, you can containerize them and running on ECS. If you are .NET Core, even better. It's much easier. But if you are dealing with .NET Core, then we have even better service for you. It's called Fargate, and Fargate is just like a serverless container service from Amazon and from Amazon Web Services. And the good thing with Fargate is that Fargate will, it's just like Elastic Beanstalk. Instead of dealing with the virtual machines, you are dealing with the containers. So you just write your code and containerize it and pass it to AWS. AWS will create all the backend for you. It will set up auto scaling. It will set up the infrastructure. It will set up multiple instances. It is, for you, it's like serverless because you are not dealing with any servers. And it will run your servers in containers in Amazon Web Services Cloud. I'm going to do a quick demo for this in a minute. But let me talk about like, so as I said, there is no cluster you manage. There is no manual work for you. Amazon Web Services, AWS takes care of everything for you. And it does integrate with different AWS services as well. So, and like 21st century, a lot of people, they ask about Kubernetes. We do have a service about that you can run your applications, your .NET Core applications on Kubernetes on Amazon. The service we have is called EKS, Elastic Kubernetes Service for Amazon. And there is a lot of documentation on how to bring up a Kubernetes cluster with minimum work and actually deploy your .NET Core applications as well. So one of the resources, if you want to try it yourself, is we have a video series on YouTube called AWS for Microsoft Workloads. I really encourage you to go there, and there is like multiple videos to show you how to set up and run your Kubernetes cluster, deploy your .NET Core applications, and even maintain your cluster over there as well. So before going forward, I want to do a quick demo for you of how to deploy a .NET Core application, a containerized .NET Core application to AWS Fargate. So right now, this application that I'm showing you, again, What I didn't do, this is no magic here. I just went new project, create ASP.NET web application, the ASP.NET Core web application. I just created a web application, and the only thing is I right-clicked on it, I said add, and added the Docker support here. And when you do this, Visual Studio is powerful enough to create the Docker file for you. And this Docker file, it actually says, like from this image, from this Microsoft, from this image that Microsoft, the .NET Core image that Microsoft provides to you, like install the IIS, like copy my application, make my application running, set up the port and everything. So from here, I'm going to, this is my application. I didn't even write one single line of code. Assume that you have done your coding here. We'll right-click on this and say publish container to AWS. And here, the only thing you need to do, I'm going to like deploy it into like US East, the North Virginia region. You can choose any other region as well. Click next, and it's going to choose a name. The launch type is Fargate because I'm choosing .NET Core. If I was dealing with like legacy .NET applications, I couldn't go with Fargate. I should have gone with EC2 instances. That would be a cluster of EC2 instances called ECS that I talked to a little bit more. You can put like, hey, this is the maximum CPU I want, this is the maximum memory, this is the network that I want to deploy my code to, and I need like 2 tasks to be deployed. If the minimum percentage of running task is 1, and each task, think about it as one container. So this one is saying that, hey, when you scale, don't scale down, like at least always have 50% of 2 instances, at least always have 1 server running, and don't scale over 4 containers at any time. And you can go to next. You can set up in the next screen. You can set up the load balancer. Again, my laptop is a little bit slow, and I clicked it twice. And you can publish your task definition. Task definition is just whatever you have for your container. You can say that, hey, just create a new task definition for me. I don't want to do anything manually. And click publish. And what happens is that I'm not going to do this now because I'm saving you time. So if you go to Elastic Container Services here, you can go to clusters, and you will see something like collision demo prep. And I already created this demo. I already launched publish, and I already like containerized my code, uploaded the image to the cloud, and it will deploy everything. If I click at the tasks, you will see that there are 2 containers running at the moment. There is all the information about like these containers provided here. They have their public IP and DNS and everything. And Amazon Fargate not only deployed my code, my container to Fargate, but also it gave me, set up the health check and gave me the URL that I can click on this. And this is my container. This is exactly the same code that I ran on my laptop running on the cloud. And you just, with a couple of clicks, you deployed your code to Amazon Fargate, .NET Core containers on AWS Cloud. So let me move a little bit faster. I'll try to save some time at the end for the questions, but so let's have a quick talk about serverless. And when it comes to .NET Core, what are the options you have? And when we talk about like serverless in AWS, the first thing that pops up is Lambda. And Lambda, when we talk about serverless, it doesn't mean that there is no server. There is server running. There are servers running in the backend. It's just they are not visible to you. You don't need to be concerned about them. You don't need to think about, hey, is the network secure? Is it like up and running? Is it like, how is it working? And like AWS takes care of that for you. And the sweet thing if you don't have, for example, your Lambda function called in 5 hours, you are not paying a penny for that. If people start calling your Lambda function, then you start paying per number of calls or per 100 milliseconds that's running, or and it's different prices for the memory that you're using. I'm going to give you an estimate or a sense of feeling how cheap AWS Lambda is. I would say that this is my personal experience. If you are not doing Bitcoin mining, anything else you're doing, it would be much cheaper if you go with Lambda. So, hello. Did I go 2 pages? No. So, about the pricing, assume that you have a blog that has and you have 16,000 requests per day, and each call to and each API call takes 200 milliseconds. So if you are running 2 EC2 instances, if you are using reserved option to save some money, and you're running that you are paying for reserved instances for 1 year and 2 instances in 2 different availability zones. And the reason I'm saying is that if one of them it goes down, the secondary one or the other one can take care of all the load. You end up paying $2, less than $3 per day. And these numbers actually will lower the prices. It's very possible from the time I made this slide up to this moment, Amazon loaded the, reduced the price. And these prices are for the Virginia region when I created these slides. But if you go with Lambda, the same solution, it will cost you 5 cents per day. So you can think that how much money you can save, and this is 16,000 requests per day. You can think that how much money you're saving running your .NET Core application on Lambda. So how can a Lambda function be triggered? There are different ways to trigger a Lambda function. And I'm sorry that okay, you're seeing it fine. I don't see that fine on my screen. So there are different ways to trigger a Lambda function. One of them, for example, if you put an object into an object repository like S3, that can trigger a Lambda function. For example, it's a use case for that. You can write your own mobile application that takes a picture from somewhere, uploads the picture into S3 repository. And from the S3 repository, you can have a Lambda function get triggered that it will, as I said before, send your picture to Amazon Recognition. It will see that what are the items present in the picture. For example, there is a chair, there are people, there is a screen, there is TV, there is a cat. And it can tag those strings to the picture and put it back in the image repository. And you can actually do some with minimal effort. And this example that I told you, the Visual Studio, it has a blueprint code. It has a code template for that. So with in matter of 20 minutes, you can what I told you here, you can actually build it up yourself. There are other ways to trigger Lambda functions. You can trigger a Lambda function from API gateway, and API gateway is the front end to your application. So assume that you have a school and you have an API get students. You can go to API gateway, set up the API get students. In the backend, if somebody calls get students, it can call a Lambda function. It can trigger a Lambda function, and that the HTTP response to that Lambda function, that can actually be a full website. You can bring up a full static website in Amazon Lambda as well. And what are the use cases for Lambda? You can do the backend for your web applications. You can do that. You can do real-life processing if, for example, you have a stream of data coming, and each of them you need to do ETL functions for that data. You can use Amazon Lambda with that. And Amazon Lambda, it can work with different AWS and Amazon services as well. So, as I said, there is no servers to manage. It's not that there are no servers. There is no servers for you to manage. There is continuous scaling. So one of the things I do motivate you guys to go set up a load balancer, a free one like JMeter, and use your Visual Studio. I'm going to show you how to set up a web server or web API using Visual Studio and just deploy it to the cloud. Deploy an API to the cloud, set up a load balancer, and try to bombard that API from that the load runner or load generator, and try to see how much load can Amazon Lambda handle. And I tell you that I was doing that like this morning. I was like increasing the number of parallel threads and like the number of users and like transactions per second, and like the number of and the processing time. It was a matter of single digits or like 10 milliseconds, something like that. That's the network traffic actually. It's very fast. And whenever you're not using that application, you are not paying for that. So how does it work? You bring your code, if it is .NET Core, if it is Node.js, if it is Java, if it is Python, you just bring your code, and there are different ways to give it to Amazon Lambda, to deploy it to Lambda, and you set it up that how much memory your application needs. Does it need 120 meg, or does it need like 2 minutes? And the only caveat is that Lambda, your code needs to be stateless. You shouldn't keep anything in the memory. Like, you shouldn't think that, hey, there is a virtual machine or there is a container. It will keep like state of my code. No, there are like, don't think of the session state provider. Don't think of it like in a monolith way. Think about like a stateless, like microservice way that whatever you compute, whatever you get, you have to store it in a database. You have to store it like in either like Elastic Cache, Memcache, Redis, or DynamoDB, or some database. Don't assume that if you keep something in the memory, the next Lambda call like has access to what you saved in the memory. And let me just quickly go to Visual Studio and show you how to just bring up like a website, a static one. You can do that with an API, or you can do, there are different blueprints. You can do that Amazon recognition image processing that I told you here as well. But I just want to do a quick demo here. So I'll go to File, New, Project, and I will search for AWS. And there are many different blueprints here. I'm going to choose AWS Serverless application. And next, just call it whatever and create. Again, it's trying to create it. Now it's giving me the options. Hey, do you want like serverless application, or detect image labels, or like a web application, or just a web API? In this scenario, I just go with a web application. I click Finish, and it's going to create that for me. Like, it probably, again, my laptop is not on the performance mode. I'm trying to save battery for this demo. So, and it creates the application for me. Just let's give it another minute. Actually, I have another application. Oh my God, this is slow. Come on. So until this loads, I'm going to tell you what's going to happen. So this serverless application, you can actually run it locally. It's just like a website that you can get access to it locally. And, or I can just, the same as like deploying to containers or deploying to Elastic Beanstalk, I can right-click on my application, and I can deploy my application to the cloud. So right now, let me just increase the performance of my laptop a little bit more. So, okay, since this is slow, let me talk about DevOps, and I'll come back to this demo at the end. So let's quickly take a look at the DevOps and CI/CD for .NET and .NET Core applications on AWS. And so when we talk about DevOps, there are different stages that we are talking about. There is source. For the source, usually people like nowadays, they use like GitHub, or like previously there was SVN, Subversion, Perforce, different like kind of repositories. The most like used ones nowadays is GitHub, and AWS does provide you its own version of code repository called Code Commit. Still, you can use any kind of like Git repository as your repository as well. For the code purpose, we do have code build. Code build does support build for .NET Core applications. It does support build for Windows .NET applications running under Windows as well. For test, we do have a lot of partner services that you can use their applications to test your application. For deploy, there are different services that we provide. The most commonly used one is Code Deploy that I'm going to quickly touch in this presentation. And there is provisioning of the infrastructure that you can use CloudFormation for that. And there is monitoring that you can use CloudWatch. So this is, we do have a service called Code Pipeline. Code Pipeline, it's just a combination of a source, build, staging, and production pipeline that you can create. And you can go to the Code Pipeline and create on the source and say, hey, this is my repository. Then click on build and say, hey, I want my build to be like by AWS Code Build or Jenkins or Microsoft like Team Foundation services or whatever. You can have like a staging for like, that's going to be the partner tools that you can use. And for production deployment, as I mentioned, there is Code Deploy. So just quickly touching base on like each of these services. Code Commit is a fully managed repo. It's Git compatible. It works with different AWS services. It's just like the Git repository that you need. If you need something if you don't have a Git repository yourself, you need something from AWS, we do have Code Commit. For the code build, if you are using Jenkins or UTFS or whatever like build system that you're using, you can keep on using that. If not, we do have code build that it will build your application and it will like package your application for you. We do have Code Deploy that it actually like, it will take the package code and it can deploy it to virtual machines, containers, serverless, and different like solutions for you. And Code Deploy, you can do it one deployment at a time. You can do like half at a time. You can do all at once. You can do like blue-green deployments and like canary and different kinds of deployments. AWS Code Deploy does handle that. And at the end, another demo, if time allowing, I'm going to show you is AWS CodeStar. And AWS CodeStar is this service that it will create the whole code commit, code build, code deploy. It will deploy your code and it will give you a URL for your web application that you can actually go like. So as a developer, you just need to write your code. Amazon will create you the CI/CD, create the CI/CD pipeline for you. So I'm going to hopefully do a quick demo for that, and that's what Amazon CodeStar is going to create for you. And at the end, I want to quickly like touch on CloudFormation. And Amazon CloudFormation is that if you are startup, even enterprise, even like anything, you will have assume that you will have different environments. You will have different regions. One way is to go and create them manually. You don't want to do everything manually. You want everything to be automated. That's the manner that DevOps requires. You don't want anything manual. You want everything automated. So there are different tools in the market. Like you can use Terraform, but the most powerful one that works like under AWS is called CloudFormation. And CloudFormation is you put like whatever you need in a JSON or a YAML document. You say that this is my network, this is my instances, this is my availability zones, this is the ports I want to be opened, and everything. And you will put everything in that document. You will feed that document to CloudFormation, and CloudFormation will go and create that environment for you. And the good thing is that if you notice that, hey, I need more ports to be open, or I need like more servers to be up, CloudFormation, you can apply that to the JSON file, feed it to CloudFormation again, and it will only deploy the delta for you, the difference. So before going to CodeStar, Hopefully my Visual Studio is running now. Yeah. So this is the template that the AWS toolkit has provided for you for your serverless application that I created. So I can click on Run under IIS, and I can run this website locally. And again, my laptop is a little bit slow. And what will happen is that you can even run the Lambda function, the serverless function, locally on your laptop. So what happened? So I can click here, run. So this is, if you run the serverless web application, the blueprint, it looks like this. Going back to the application, it has all the pages and layouts and everything over there as well. Another thing I'm going to show you, I can right-click on it. I can publish this to AWS Lambda. And from here, I just need to put a name, a stack name, and click Publish. And I'm not going to do that right now. I'm running out of time. After you publish that, it's going to create you. It will deploy your code to AWS Lambda, and it will give you a URL. And if I click on this URL, this is my website running on AWS Cloud. So what I'm saying is that after you go there, after you deploy this to AWS Cloud, try to run a load test on that and try to see how if you can slow down or break Lambda. I bet it's going to be very hard. My last demo that I'm going to do for you, I did talk about CodeStar and this product that we have that can create all the build pipeline for you, specifically if you're doing .NET Core application. So in my AWS console, I will go to CodeStar. Again, I'm sorry, my network is a little bit slow. I have already created, wait a second, I've already created a demo, but let me show you how to create everything from scratch. I'll create a new project, choose C#, you can choose any other language you want. Do you want a web service or a web application? I say that I want a web application. I want to call it collision demo for Shahab. I click next, and it says that I'm going to set up everything for you. I say create the project for me. This is going this is the SSH key that if I want to connect to those servers, I say that I'm going to use my own SSH keys. I'm going to create the project. It says, do you want to use, if you are using Eclipse or Visual Studios or any of these IDEs, you can connect your IDE. Right now, I'm going to skip this. And it's going to create everything for me. This takes usually 10 to 15 minutes. So what I'm going to do, I'll go back to the demo that I already created for you. And after it finishes, it will look like this. It has the source set up for me. I can click on it, and I can see the code commit, the Git repository details here. I can click on build. I can see what build process is, like on this blue one, what build process is using. And I can click on deploy. And I can actually add stages to this if I want as well. It's actually monitoring my application, the CPU utilization as well. And it's actually not only it created and deployed my application, it provided me with the application endpoint here. I click on the endpoint, and this is just a template project that it uploaded for me. It deployed the template project for me. So you need to replace this template project in your code repository with your own code and start just using your this pipeline and enjoy it. So AWS, you just do the development for your .NET Core application, and AWS takes care of everything for you. So thanks a lot. I'm at time, so if you have any questions, please go ahead and let me know. Thanks a lot.